Now let's continue to look into some more operations under this Numpy arrays. Now in this case, if you want to sum up the elements in the array, then we can first create the array and then use the method sum. Here we are creating the array with 2 by 2 dimensions, 2 rows and 2 columns, and we apply this sum on method from this Numpy arrays on this matrix ex1. Now when you execute this, you get sum of all these elements, 11 plus 12 plus 21 plus 22, you get the result as 66. Now, if you want to get only the row values sum and column values sum separately, then as we did in the previous case, we can mention here the axis. If you want to get the column wise sum, you can give the axis as 0, and the row wise sum, you can give the axis as 1. So for this, you just execute and see. Call a row wise sum, 11 plus 21, you get 32, 12 plus 22, you get 34. Now that is column wise sum. Now if you want the row wise sum, then you can get it as 11 plus 12, you get 23, and 21 plus 22, you get it as 43. This is how we can apply sum across rows and columns. Now there are some element wise functions also. Say if you want to find maximum of row values or minimum of column values, then you have those methods available in Numpy arrays. To demonstrate those functions, let us first create some matrix a single dimensional array, one dimensional array with some random numbers. Again, they are according to normal distribution. That is why you are using rand n. And for x, y also we are creating a one dimensional array. Now, if you want to compare the numbers in one dimensional array x with the numbers in one dimensional array y. Say the zeroth index value, if you want to compare that zeroth index value from x with zeroth index value in y, you can do that by using np.maximum method. np.maximum method will take element wise values and compares it against the other values in the other array and finds out which is the maximum that will be displayed. So when you execute this command, you can see among this value and this value, this is the maximum. This value and this value, if you consider, which is the maximum, this one, right? So that value will be displayed. This is how maximum function works. Element wise maximum can be found by comparing two one-dimensional matrices. Now let us create some values between 0 to 20. Okay, so you have a one-dimensional array here, and from this one-dimensional array, from this list of values, if you wanted to create a matrix, right, you have the values as a list of values. Now if you wanted them to rearrange into a matrix by with the given dimensions, you can do that by using reshape. Reshape, what you are reshaping? The array that you have created. You are reshaping with dimensions 2 and 10. Okay, so all these elements that are created will be arranged that dimension should be compatible. Say you have 20 elements, but you are using 2 by 2 matrix, right? Then it will miss out some elements. So in this case, you have 20 elements and you are reshaping it into 2 by 10 values. when you try to reshape it into a 2 by 2 matrix, then it will give error because you have 20 elements, but you are allocating space for only 4 elements. That is why it gives an error here. Can't reshape array of size 20 into shape 2 by 2. This is how reshape method works. So let us now change it into 4 by 5, which will give us the matrix as 4 by 5 matrix. Now, if you want to find the transpose, we have already seen this, right? You apply dot T on the array, which will render the array with its transpose, in its transposed format. Actually, the rows are 11, 12, and 21, 22, but you get the transpose of that array. Now, another important indexing can be done by using where clause. This is very important when we are going through the, say, when you wanted to apply a particular operation on some set of values under a column and doesn't want to apply that operation on another set of values under the column, then you can just filter them out. Whichever values you are interested in, you can filter them out, apply operation on it, and just do not touch the other set of operations. That can be enabled by using this where method. Now let us see, here we are creating two one-dimensional arrays, x1 and y1, and we are also creating a filter here. This filter filters out whichever value at this index number, that will be filtered out, and whichever value comes across this index number, that will not be filtered out, okay, because it is given as false. If you apply it on x1, it is easy to understand. But you are applying this filter on x1 and y1 also. Means this filter behaves the original way on x1, but behaves the opposite on y1. Let me explain you once you get the result. Now you have to first execute this and this one. Now you can see first this filter applied on x1, right? Now what are the elements in x1? 1. Now what is the corresponding filter value here? True. So 1 is filtered into the result. Okay. Now next value is 2 and the filter value is false. So it is not filtered out. Now again next value is 3 and the corresponding value in the filter is true. So 3 is filtered into the result. Now 4 is not filtered because it is false, and 5 is extracted into the result because it is having true in the filter. Now this same filter acts the opposite way on y1. When it is true, that element is not taken. When it is false, that element is taken. Did you notice here it is 22 which has the corresponding value as false. So that 22 is retrieved into the result. Again 33 is not retrieved, but 44 having its corresponding filter value as false, that one is retrieved, and 55 is having true, so it is not retrieved. So when you apply the filter using a where clause, it acts like a ternary operator. If true, apply to this, only else apply to this, right? That is how where clause works. Now here in this example, you can see some random numbers being generated with the given dimensions. Now you can see here the random numbers are all positive values. When you use rand, you doesn't get any negative value. If you execute this once again, you can notice all the elements that are being generated are positive values only. So if you want positive random numbers, then you can use rand. right? If you want both positive and negative, you can use random. If you want only integers, you can use randint. Right? There is very little difference between all these methods. So as you go on working with them, the confusion will be resolved. Now see here on this particular matrix that is created, you are applying the filters here by using the where method. So you should be at most careful in understanding this result. We are using where clause, which adds the correct original way on first filter and on first filter and opposite way on the second filter. So what do we mean here? What is the filter here that is given here? If the matrix element is greater than 0.5, then make it as 1000. If it is not 0.5, then make it as -1. Okay, you understood now the importance of where. If you want to apply operation on specific values and want to apply a different kind of operation on other set of values, then you can use this where clause. Wherever this condition is true on this matrix, apply this. Wherever the condition is false, apply this. Okay, so wherever this condition is true, say this is greater than 0.5, so it becomes 1000. This is lesser than 0.5, so it becomes -1. Here it is greater than 0.5, so it is embedded with 1000, and here it is lesser than 0.5, so it is embedded with -1.